Okay, so now I'm starting, so hope you are able to see my screen and then also able to hear me and see me. Perfect. It's going good. So let me, okay, just a minute. I just have to, yes. Great. Awesome. Okay, so let's make this interactive session. You can keep sending any queries over the chat, or feel free to interrupt me or ask questions in between in case you want some clarification. Or no, we'll cover microservices architecture, and what I will also do is I will share a write-up about how to implement a microservice. So this is in continuation with the last session, but going through the hands-on exercise, I felt that this will take more time because you have to set up the Java environment, and you have to have an IDE, and then also deploy Docker Kubernetes, and then you have to configure it, and then run the microservices, also code and test the microservices. So this will be a lot of stuff to cover in one session, but what I'll do is I'll go through the concepts, and then we will I'll share a write-up so that you guys can try out at your convenience when you want to create some web service, say product web service. But yes, we'll go through in this session more in depth on the design principles which are involved in microservices architecture, right? So here we'll just start some discussion from some very basic stuff. Okay, so let me put down the agenda for this session, right? So in this session we will be covering a lot of stuff around microservices, and which is starting from, first thing we'll understand what are microservices, and then we will also look into benefits of microservices and why they are becoming popular. Then we will cover about communication between microservices. I have already covered many of these items in the earlier sessions. There was a session on microservices patterns, but yes, again we'll discuss here communication across microservices in depth here, and we will also look into various infrastructure elements which are required to set up microservices. Say for example, we will cover about service discovery, right? Again, this is an important principle, and then about registration of microservices, how to run a real application with many microservices, thousands of microservices, and then definitely this infrastructure element is very important here. We'll also cover about API gateways, what are the facilities which are provided, how it overcomes some of the drawbacks of microservices, and then we'll talk about deploying and scaling microservices. Right? So this is the topic. Let's begin with what is microservices. So when I say microservices, what do we understand? Okay. So with the definition of microservices, first thing which is very clear is, earlier we used to have a big application, and definitely you had multiple modules. So you may have 1, 2, 3, 4 different modules, and this is a traditional application. This is a monolith app, right? Monolith applications are also, you would have understood that they are component based applications, right? They also had layering, so they had something called layered architecture, right? And they definitely had a database, a central database, where they have the data is stored. So all the applications earlier were very well organized application, and they had different layers like presentation layer, database layer, and and the front end layer. Now in microservices architecture, what we do is we divide these application into services. So you have the same services, but they are smaller services. They are independent, and they are deployable, independently deployable services. So here, we broke down any application into smaller application, and this makes it microservices. And these are services, and these services have these qualities, like they are smaller in size, and they are independent. They can work independently, and they are deployable separately also, right? So basically, microservice architecture is a architecture style. So microservices, when we say, is a architecture style. By architecture style, we mean it contains following things. It is set of guidelines. We'll see what are the guidelines. There are set of principles, and there are set of patterns. Right. So when we talk about different architecture style, okay, so for example, I spoke about a monolith app. What other architecture styles do you know? Right? Anyone have heard about or have known various other architecture styles? I list them all one by one. So we discussed monolith architecture. So monolithic is a architecture style, right? Then we can say there is another architecture style which is event driven architecture style. Then we have something called layered architecture style, right? We discussed also event driven. Let me discuss now. We haven't discussed other architecture. There are several other architecture styles. One is serverless architecture style. This is also something which is a modern architecture style. And then we have something called component based architecture style. So these are various architecture styles, right? So let's talk about each of them one by one. So what makes any application a monolithic application? We already saw. This is a traditional approach. So monolithic approach is a traditional approach. Okay. And here systems are tightly coupled and everything is in the single code base. So when I say monolithic app, we have a single code base, and you definitely have deployable units, but they are you have multiple, it's not the case that you have only one deployable, you have multiple deployables, but everything is coupled. They are not loosely coupled, they are tightly coupled, and there is some problem with this. The advantage is it's simple, it is very well structured, layered, and the challenges are it is difficult to scale. This is the first cell challenge, and the second challenge is it is difficult to maintain and evolve, right? Because the problem with monolithical architecture is, I'll cover that also, just a minute. So yeah, we saw this is a monolithical app. The problem with this is that as the time goes, we have to do a lot of modifications. Since the components are tightly coupled, most of the team, they have to work very closely with each other. So when the teams have to work closely with each other, then this is a problem that you have to put a lot of coordinations, and the speed slows down, because if you have to update something in component 2, you can apply a patch into this, a small patch, but the problem with this patch is that when you restart 2, then other components also will get impacted, so you have to test them, and you have to ensure that maybe you have to restart all these other components as well, and becomes very hard to evolve over time. So this is the drawback about a monolithical application. There is another architecture style, which is event driven architecture style. We'll cover here, and here the idea is in event driven architecture style, the main idea is, just a minute, I lost my screen. Okay, now, so in event driven architecture style, we have a lot of events. So it's built around idea of events. Okay. And these events, basically event is the mechanism through which multiple components will interact with each other, right? So this is about event driven architecture. What are the advantages of event driven architecture? So here you have different systems, they can work with events, and you generate events, so you get a lot of flexibility with respect to how you can communicate. And then there is disadvantages. Debugging is difficult, because a lot of components, they interact in different ways, and events get passed from one system to another. So it is difficult to debug and to understand how the system is working as a whole. Great. Yeah, so CQRS pattern we looked earlier, and then we also have another layer, architecture style, which is layered architecture style. In this you have various layers, and there could be several layers. So this is generally also referred to as n-tier architecture or multi-tier architecture, 3-tier architecture. And this is easier to manage, but still there can be tight coupling between the layers, right? So this is disadvantage in layered architecture also, is that it is hard to maintain. Right. So we'll cover gradually other aspects as well. We'll go to containerization and deployment, and so these are various architecture styles. Now my question is, assume we are given an app and we have to design the app. How can we make sure that which architecture style is the most suitable one, and how to choose which is the appropriate architecture style? correct? So any ideas about how to decide which architecture style will be suitable for our application? To choose between different architecture style, the main guiding principle is you have to understand the requirements in terms of scalability, and what are the trade-offs you have to do. So maintainability, scalability, performance, right? So if you really need a high performing app, definitely monolith app is the good architecture, because here all the calls, if you want to call from module 1 to module 2, what you need to do is just we have to call the code. Maybe you may need to call the object and method directly. You can call, because you have a single code base, and there is tight coupling. So the call will be just calling some other object in the same memory, and they may take some microseconds or even nanoseconds to interact between different components. Now, but when you change your architecture to microservice architecture, these components are independently deployable. So when you call one component to another component, there is lot of overhead and network latency which will also come into picture. So from nanoseconds of communication, right, you are moving to milliseconds of delay between the calls. So this is a performance overhead, but in long run you gain a lot, and you have ability to adopt the application, evolve the application, and for large scale application this is very suitable architecture, microservices architecture. So now let's talk about what are the real benefits of microservices architecture, and then we'll design an app using microservices architecture. So first thing is, there are a number of benefits of microservices architecture. First, we already saw that each service can be developed parallelly, right, without much coordination. So you can have in microservices parallel development, and not only parallel development, you can have parallel deployment, testing. So all the phases could be parallelized. So you gain agility as a result of microservices architecture. Right. Other benefits are that you can scale the application independently. You can scale each of the microservices or components independently. So if you need some service which is to be scaled much larger than the rest of the application, then you can have more computation, more memory to a particular microservice. This was not possible in monolithic app, because if you have to scale a monolithic app, you have to increase the system requirement of the entire application. You can't scale selectively one microservice. And third thing is simplicity. Simplicity, or I would say ease of development in microservices. So not deployment, ease of, I would say, development. Right. Okay. I think my screen is not getting updated. Let me try to see what's happening. I'll represent again this screen. So this way you'll be seeing again my content, which is the latest updated content. Right. So, okay. Still the same result. I'm not able to scroll with respect to my screen. So let me try doing this again. I reshared, but still this is somehow not updating in the just a minute. Okay, yes, now I got it back. Okay, maybe this is some optimization which was done by this screen sharing app, which is causing a bug, and I just noticed that okay, I was updating something but this was not getting shared. Okay, but yes, I refreshed it and now this is working smoothly. Okay, great. So yes, we were talking about ease of development with respect to microservices, and I will share a write-up with which you can kind of develop on your own a microservice. But yes, we were just discussing the advantages of microservices. Anyone want to share more advantages of microservices? So another advantage, I would say, it is more fault tolerant, right? So fault tolerance is another advantage of microservices. So these are the various advantages of microservice. Great. So I see people have posted some comments. So testing of microservices could be done individually. So you can perform unit testing as well of microservices with ease, and you can also do the integration testing also, or the acceptance testing as well. So about the testing strategy, that could be a different topic, but yes, that is also relatively no less complicated. And then deployables are small in size. Okay, yeah, that's another advantage of microservices, but you can have also deployables small in size in any other architecture also, not necessarily in microservices, because deployables are the components. So you may have multiple jars or multiple vars or EAR files which could be there in the microservices architecture as well. Just give me a minute. I will just resume in a second. Yeah, okay. So these are most of the important advantages of microservices. Now, as we talked about earlier, that microservice architecture is set of guidelines, set of principles, set of patterns, right? So now we also discussed and understood that microservices have various advantages. So these are the advantages why it is becoming so popular. So if you have to design some app which is a complex app like e-commerce application, I would say no. Say for example, if you have to create an e-commerce application, so microservices pattern is a suitable pattern for this, right? Now when we design any application, what are the principles which we should follow, right? So few of the principles you would know already, these names. One is single responsibility principle. Okay. Second is you should have loose coupling. Yeah, we discussed all these we already had a session on solid principles or LLD, low level design principles. So these are some of the principles which are very important in microservices design, right? And high cohesion as well. And then fourth is autonomy, and other principles, I would say the microservices should be stateless, and then there is another principle which we called smart endpoint and dumb pipes, right? So this, and then it should also monitoring and logging is very important in case of microservices, right? So yeah, these are the important principles which you should follow. 7 important principles that you follow for designing any microservice or any app which is built using microservices architecture. So let's go through each of them very quickly. So first one is single responsibility. So this is also you should have separation of concerns, and a particular microservice should be responsible for one specific business function. So all microservices should be responsible for one specific business function, right? So this is one important guiding principle. About loose coupling, we should say that there should be minimal dependency between microservices. Then when we talk about high cohesion is that related components or code should be together, right? Right, so this is about the high cohesion. When you have high cohesion, it is easy to maintain. When you have loose coupling, the application is flexible. Then you have something called autonomy. Autonomy says that the microservice should be able to function autonomously or independently, right? So microservices should be working independently. It should not be depending on other services to be up and running for its proper functioning. And then we talk about statelessness. Statelessness is very important for scalability, and microservices should be stateless. They should not maintain any state information. State information should be maintained in some central storage. So statelessness makes the microservices is scalable and fault tolerant as well, right? Because you can run multiple instances of different servers, and in case one server instance fail, you can rely on other to take its place, since the state is maintained common in a common manner, so you don't have any dependency on a particular microservice. Great. So now let's talk about this new principle, which is smart endpoints and dumb pipes. So this means that the business logic should be there in the endpoints, right? If you have a microservice, microservice should contain the business logic, and the data transportation should be the responsibility of the pipes, right? Or yeah. So when there are communication between two microservices, so you should have your microservices, which is built in two ways. You should have an interface, and if you see the REST principle, they are around this, because you have lightweight protocol, and your business logic, which is heavyweight, is in the microservices code itself. And about monitoring and logging, you should build your microservices with monitoring and logging in mind. So any doubts until now? Is it fine? Now let's go into the complicated parts, which is around how to communicate between different microservices. So we'll talk about communication between microservices. There are number of ways to communicate between microservices. Anyone would like to take this? First is, yeah, tell me.
Kafka messaging queues?
Sure. So which we can call asynchronous communication.
Right.
So this is one way to communicate between microservices. There are other ways. The communication could happen between client and microservices, or across microservices as well. We also discussed last time about various protocols for communication between microservices. So synchronous communication, what do we mean by synchronous communication? Synchronous communication means that if you have two components, one is sending some request to another component, then this component will be waiting for the response to come, right? So this is synchronous communication. We generally use REST or GRPC, or there are other ways also to communicate, for example SOAP, or sometimes there are other protocols also we discussed last time, Thrift and AVO, and there is one more which is JSON RPC. So there are various protocols which can be used for doing asynchronous communication, for synchronous communication. For asynchronous communication, again there are different ways you can do asynchronous communication. Asynchronous communication is sending a request to another service without waiting, right? So this here you have the communication happening, but the first component, if this is component 1, is not waiting for component 2 for sending the response, right? So if something is time consuming, then you go with asynchronous communication. This is one of the guiding principle. If something is instantaneous, it does not require a lot of processing, then you can go with synchronous communication. Now, event driven architecture, which we discussed, mostly relies on asynchronous communication. Correct. Now, there are other ways also to communicate. I would say the other ways to communicate are we can communicate using a mechanism called API gateway. We can communicate using service mesh, right? I'll tell you what is these components. Service mesh, or you can say it uses a concept of service discovery and registration, right? So this is about different ways to implement the communication. Now, when I talk about API gateways, anyone would like to share something? What is an API gateway?
It is used to secure the APIs that is one of the.
Yes, correct. So API gateway is another component in between, right? So when component 1 and component 2 are communicating with each other, right? Suppose you have component 2, so all the communication will happen with API gateway, and API gateway will take care of all the umbrella activities. For example, it can take care of authentication, authorization, right? And lot of other stuff, right? It can even do logging, monitoring. What else? API gateway can do caching. It can do load balancing. It can do routing. It can do rate limiting, and many other functions are there. So anything which is common across multiple microservices, you can do it with API gateway. So it helps to offload your microservice with all these tedious tasks or all these boilerplate coding or infrastructure related logic will be there in the API gateway, right? So again, API gateway is also following the previous principle which we covered, which is about smart endpoints and dumb pipes. So this API gateway simplifies the communication between multiple microservices. Now let's talk about service mesh, because you would have heard about this. Assume you have a application which is usually, do you know what would be the scale of number of microservices some big application will be running, right? Say for example, any guesses in Amazon for e-commerce application, okay, how many microservices roughly would be there? Right? Is it in few hundreds or is it in few thousands? Right? What do you feel? Definitely, the microservices, I would say it's wrong to say it's in few thousands. It would be many thousands of microservices which will be running, right? So this is the complexity. Now you can assume that these services will be communicating, not all the services will be communicating to each other services. There will be few services which will be communicating with each other, but few may not be communicating with each other, right? Now another problem I'll mention is, assume you have a service which is called service A and you have service B. Now if you have to make a call from A to B, right? Say assume this is a service which is called, let's say, user profile service, right? And this is some other service. Maybe this is, let's call this service as login service, right? Or whatever. It could be anything. Don't worry about exactly what service it is, but there are two services. Now when we call other service, we give the endpoint, right? You can only call by giving an endpoint, right? So generally what you do is, B, you need to scale it also. You will have multiple servers of B running because some servers may go down. You will also have a load balancer in front of B service. You will know the IP address of load balancer. You will make a call to the load balancer and load balancer will route it to any of these servers and will give you the response after processing from any of the servers. So there may be 1, 2, 3, 4 instances of B running. Maybe there could be some instances of A also running. So 1, 2, 3, right? Maybe, yeah, this could be something different and this could be something different. So you need to know all these, right? And load balancer also becomes a point of failure in this case. And if you have, say, thousands of microservices, then you will have that many number of load balancers. So again, it is complicating things to a large amount, and then for each of the load balancers you should know how many instances of a particular service is running. And when you add any new microservice, this makes it very difficult. Correct? Right. So load balancers are also of two types. One is the software load balancer and hardware load balancers. Correct. But yes, this is generally the problem which happens. So service mesh, right? Service mesh is a way to solve this. So whenever you add a new service, you have a service registry. So the service gets registered centrally to the service mesh. And this way you maintain all the mapping between the services, what instances are running with services. So when A is trying to call B, it does not call it directly because if A is communicating with multiple other services, it will need to know all the endpoints, and these endpoints may be dynamic, they may be changing, so it becomes very hard to maintain all these integration logic. So in service registry, what actually happens, whenever a new service comes into picture, it will register into service registry. And once A wants to call, instead of directly calling B, it calls first the registry and finds out the endpoint details from the registry, this phase is called discovery phase, or this is called service discovery. Right. So this is how your service mesh works. It helps you to maintain dependencies. It also helps you to discover and register multiple services. Correct. So these are various options which is available when you are designing any application using microservices architecture. Right, so now let me talk about some design process of microservices. So if you have to design an application, first thing is you have to know the domain, right, to identify microservices. For example, if you have to design a microservice application for e-commerce application like Amazon, you should know that, okay, yeah, you have various services which will be required, which is called product catalog. You should know that, okay, there is something called shopping cart, right? You have to know the requirements of all these components as well. You should know about ordering process. You should know about payments. You should know about shipping, right? So if you are designing a big application, first step is you understand the domain, identify what are the business functions. So we have these many business functions. Next thing is, after you identify the business functions, you have to determine that which of these business functions are suitable for building a microservice, right? So what functionalities, business functionalities are big enough so that they can be built into a microservice, right? Maybe for product catalog, you may, when you understand the requirement, you may find that there could be lot of microservices which can come for this component. So you have to then decide on how many microservices or how to build your microservices. Right. Manoj, you would like to talk about bounded context. What is it? If you can throw some light, that will be helpful. Okay, no problem. So yes, doing this breaking of microservices, maybe I will take another class on, there is a complete design principles which is called domain driven design. So yeah, because this is all about modeling real world business into abstract form which can be represented in computer. Nice. Okay. So next thing is, once you have the application components identified, now there are two ways. Generally you build a microservice based application from scratch, or you may already have a monolith app which we want to break down into microservices. So same process applies in both these cases, whether you are decomposing a microservice, a monolithic app, or you are building a microservice from scratch. Now once you have identified, so for each of these domains you will identify microservices, right? So now again, there is no such procedure. You need to know the domain and you need to understand the functionality, work with various stakeholders, understand their requirements and what is involved, and then you kind of make this microservices. So there is no such common technical aspect into these details. It's all about designing business processes and building application. Definitely a lot of experience is also required here to identify what should be the interfaces for microservices, etc. But things which are technical things which we should focus on is, once you have identified various microservices and components, you should think about what kind of communication should be there between the microservices, right? So which we discussed earlier, that there are various possibilities: asynchronous communication, synchronous communication, API gateways, and service mesh, right? If you have decided on the synchronous communication, next thing is you have to decide what kind of synchronous communication will you use. Will you use REST? Will you use GRPC, SOAP, JSON, or JSON RPC? There are so many different approaches also here, right? So we discussed last time about disadvantages of REST and why GRPC is sometimes suitable, and what are the other upcoming protocols. But yes, REST is very popular protocol, is used most of the time because of the simplicity and easy development it supports, right? Now right, if you choose to, if you decide that okay, you will need different kinds of communication in big application, definitely you'll need some components may be talking asynchronously, some components may be talking synchronously, and some components may be talking with API gateways, and some component may be talking with service discovery. You will have a kind of mix of different communication protocols, right? So let me share you some generic architecture of how microservice application will look like. Just a minute, I'll switch my screen and present a different screen. Yes, so I have shared. So something like this will be the architecture which you will be building for any big application like like Amazon, right? So let me try to expand it so that you are able to see here. So this is generally a generic architecture of a microservice based application. So you should understand that okay, yeah, you will be talking to a lot of clients. Then the clients will be connecting to microservices using API gateway. You have two worlds. One is the public world where the clients will reside. Then you have your infrastructure, which will be within some firewall. So this is represented by dotted line. And then you may also have service discovery module also, and then you have monitoring and logging also. Monitoring logging component can also be within API gateway, right? So some of the API gateways may provide, but because of importance of monitoring and logging, I have represented it as a separate component. So whenever his client is calling API gateway, data is also logged, and this is also monitored what call has happening. And when different microservices are communicating between each other, there also monitoring and logging will come into picture. So I have different ways of communicating. Maybe some microservices could be communicating directly, or some via API gateway and service discovery. This can be done on case by case basis. So this is how a generic architecture of microservice will be there. Right. So let me come back to my notes. I am switching the sharing. Right. Right. Yes. Great. So this is about various topics which is related to design of microservices. Okay, great. Manoj has shared some link to introduction to microservices. Yeah, so this is way beyond the introduction. So this is, we talked about communication between the microservices as well. We talked about various protocols, and then you have to also design the interfaces using REST protocol. And then if you chose to use asynchronous communication, then you have to also set up, yeah, I missed out one part, which is also you would need message queues also to communicate, because if you have something which is message oriented communication, then you will use a message queue like RabbitMQ, Apache Kafka, or Amazon also have few message queue options. Right. Even with the asynchronous communication, there are multiple protocols. One could be webhooks, other could be pub/sub pattern, right? Or you could have event-driven approach for communication, right? So webhooks, you would understand, is you are sending notification. One service sends a notification to another service when an event happens. So this is about webhooks. GitHub makes use of a lot of webhooks. So whenever you do any commit, you can have webhooks, and assume you want some notification in Slack, or you want some Slack notification in some tool like Jira, then this communication happens via webhooks. So there is a specific application endpoint which is sending notification, and based on the notification some action is taken, which is generally you see some message or communication about some updates in the GitHub. So pub/sub pattern and creating events and all is various features which are available in message queues. So now this is about asynchronous communication, and we also discussed about service registry and discovery, and we also discussed about API gateways. Last thing is about deploying and scaling a microservice. So deploying a microservice, once you have created the microservices, so it definitely you will need various components. You'll need databases, and as you would have noted in the architecture diagram which I presented, that each of the microservices has their own database. Earlier it was that you have a central database, and many components would communicate to the same database. But in case of microservices, you can use different kinds of database, and there may be SQL, NoSQL database for different microservices based on specific requirements. So here you have loose coupling also, and you will have multiple databases as well. But yes, you would have other components as well, which is web servers, application servers, message queues, and a lot of other components would be there. So for each of these components, what you do as a next step is you run them inside a container, or you containerize them. So containerize them means you have to create them, you have to create Docker containers or Kubernetes clusters, and now these Kubernetes clusters you will deploy to various cloud platforms. It could be AWS, Google Cloud, or Azure, depending on your specific requirement. So this is end-to-end process of how to uh, build a microservice based application and deploy it. So the Kubernetes clusters, once it is deployed into any cloud, and most of the cloud platform, they offer a lot of features. They support clusters natively. So as you are running EC2 instances, say for example, if you're running a EC2 instance or any computing engine in any cloud storage, then you automatically get the monitoring aspect. And with Kubernetes, what you can do, you have two options. Either you go through the web interfaces and you can see the events which is happening inside your clusters. So this is one way which is built out of the box, because most of the cloud providers, they support running Kubernetes clusters. And then they have a lot of features which is about logging, monitoring, and debugging these clusters. Other way is you install tools, Kubernetes tools, for example Minikube or kubectl on your desktop, and through command line you can query, you can perform various operations on Kubernetes clusters, like you can scale them or you can configure them to scale automatically. So this is a very vast topic, but as I will share some hands-on exercise, I will share some write-up which you can follow, and if you want to run Kubernetes on your desktop, you can do that very easily, and you can create clusters for maybe a small microservice. So maybe I will give one example of running a product microservice on your laptop over Kubernetes cluster, and also this Kubernetes cluster can be deployed into any of the cloud, right? So this is called cloud native way of development, because once you have Kubernetes cluster, you have this advantage that you can deploy it in any of the cloud, or you can deploy in any of the servers which could be within your organization, and even you can deploy it in your local machines also. So this is, same cluster, it offers an advantage that it could be run in multiple cloud instances, and if it is working in one instances, one kind of machines and servers, then you can be definitely sure that it will work in other environment also. Because if you don't containerize, then there could be a problem that porting your application across different environments could be difficult. With containerization, you get this benefit that you can build your test environments, you can build your development environments and production environments also, and then you can kind of run them into different environments. And most of the time you will see that since all the technical components are abstracted within Kubernetes clusters, it will work smoothly out of the box in any of these environments. But for deploying into production, you have to be little bit more careful, because what you will do is you'll also monitor the performance of your application, and once you deploy, you should monitor it and make sure that application is reliable and is performing as per your requirements. And also you should measure, you should do load testing, stress testings to ensure that application will be able to scale. And there are various deployment strategies also, which you can ensure that your application is available and reliable throughout the deployment phase and throughout when you are releasing new features. So yes, I have written many articles, on various phases of microservices development. So I'll share that also about deployment patterns. And last time Manoj shared about SRE related articles on observability, and then there would be other also on serverless technology, which can give you some insights into how to work with these technologies, and also these could also include hands-on exercises. So yes, today that's all I had for today, and hope you all found this interesting. Thanks for attending. Have a nice day, right? If any further questions, I can take up that. Otherwise, we can close this call.
Thank you, Tarun, for a wonderful session. In fact, people like me, where they don't have an understanding around microservices, really gave me a high level of understanding. Definitely looking forward to more sessions, such things. Thank you.
Awesome. Great.
Thank you, Tarun, for a wonderful session. Yeah, it's helpful for my career as well.
Okay. Great. Awesome. So I will also share the recording for you all to refer it later. And now onwards, probably I'm only sharing in some recordings I am sharing to people who are subscribed to my channel. I'll keep some of the recordings public or some of the recordings private as well, because I have also started taking some formal lectures, so I will be reusing all these content also. So but yes, to all the people who are part of this group, I'll share the recordings, right? And I will share the way to access the recording also in the WhatsApp group, so that you can access it. Yeah, there may be slight changes in the way I'm kind of now sharing the recording, but overall yes, it will be available to you all.
So Tarun, one question. If at all you like to do some mini projects kind of thing based on this architecture, so how do we really need to start, where to start, and also probably you like to need your guidance.
Yes. Right. So come up with some idea, and maybe come up with some proposals, and then we can discuss on case by case basis, because maybe I need to understand what kind of technologies you would like to learn, what is your background, and then we can discuss some ideas, and then probably this will take some time, but I can help you out. You can have a session with me, and then I can kind of help you out in deciding what kind of project you should take.
Sure. Thank you so much.
Great. So if no further questions, then I will close this call. Okay. Have a nice weekend.
Yeah, thanks, Tarun. Thank you all.
Thank you.
Thanks.
Thank you, Tarun. It was a great session.
Okay. Bye.
Yeah, bye.